All right, so now on to surface area of pyramids and cones. So two more shapes to add to our stuff. Again, it's the surface areas or like outside skin of your shape. All right, so a pyramid is a polyhedron, so again, a 3D shape with one base on the bottom and then triangular sides that come up and meet at the point. So you could have the base be anything. It could be a square, it could be a circle, it could be a triangle, a hexagon, a pentagon, an octagon, whatever. The base needs to be some sort of polygon. And then all of your sides have to be triangles so that they then come up and meet at the top. So this is your standard square pyramid. But again, you can have any shape on the bottom as long as you have triangles coming up to a point. Here, your height then is coming from the top straight down, and it has to be a 90-degree to your base. And then your slant height is the height of like the triangles on the side. So like the height like this. So this would be your regular standard heights up and down. Your slant height is the slanted height. All right, so the formulas. A note here, you could still find your areas by making a net, find the area of your base, areas all the triangles on the side. That would still give you the surface area. But if you want the formula, you're going to take the lateral area plus the base area. So the cylinders and the prisms we did yesterday had 2 times the base area because you had a top base and a bottom base. This just has one base, so you just need one base area. Lateral area is still all the sides. So you want P is still your perimeter of the base. L now is your slant height, so the slanted edge. Lateral area, base area, same definitions that we had before. So then if we're going to plug this lateral area into the formula, your surface area you could rewrite as 1/2 times the perimeter of the base times the slant height plus the base area. Okay. So some examples of what this is. Here we have a hexagonal pyramid, so hexagon on the bottom, and you have to find the surface area. So we'll write out the formula. You want 1/2 times the perimeter of the base times the slant height plus the base area. So we can find the perimeter first. We have one edge is 6, and since it's a hexagon, each side is going to be the same. So you use 6, and we have 1, 2, 3, 4, 5, 6 sides times 6 to get 36 for your perimeter. Here the slant height is labeled, so that's 9. So you have 1/2 times 36 times 9, and then we have to find the base area. So here again, this base area is going to change based on what shape you have. So since we have a hexagonal prism, you're going to use the 1/2 NSA formula for a regular polygon. So n is our number of sides again. So you have 6 sides. S is your side length, which is 6. And 3 is your apothem, which is going to be right there. So 3 square root of 3. And we can bring down our 1/2, 36, and 9. And then you can just type all of this in all at once, or you can find the 2 chunks separately. So your lateral area is going to be 162. And if you type this in, you'll get 93.5. So total, you should get 255.5 inches squared for the hexagonal prism. So our next example, here we have the pyramid is in Rome, Italy. We want to use this picture down here and find just the lateral area, and then we're rounding to the nearest square meter. So in Schoology, or sorry, not Schoology, Math Excel, you've done this before, you need to do careful rounding. So make sure you're reading the instructions, you're rounding to the correct spot. So here, if we want to find the lateral area, we need 1/2 times the perimeter times the slant height. So our perimeter, we can figure that out pretty easily. There's 30, 30, 30, 30. So 30 times 4, or 120, is the perimeter. But we don't know what this slant height is right here. But you do have a handy-dandy right triangle. So to figure out the slant height, you're going to have to do your Pythagorean theorem. So we could say this down here is A, B, C. This whole length is 30. This chunk is going to be 15. So if I redraw this triangle, we're going to get 15 here, 36.4 from here, and then we're looking for the hypotenuse. So you can do 15 squared is 36.4 squared equals your lateral height squared. Keep going with this, you'll get 1549.96 is your lateral area squared. Take the square root, and your lateral height is going to be 39.36 meters. So then we can plug that back into our original here. 1/2 times our perimeter of 120 times the slant height of 39.36 will give you 2361.6 meters squared. And then again, we wanted the nearest square meter. So your final answer is 2362 meters squared. All right, next a cone. So again, a cone is the same idea as a pyramid, except it has a circular base. So instead of having a square, rectangle, a hexagon, you have a circle, which then means you can plug in formulas for a circle to figure out a different formula. So this pi r here just comes from your circumference around to find your lateral area. And then the pi r squared is the area of the base. So here we have a radius of 4, a slant height of 9. If we wanted to find the area or the surface area of this, you want pi times your radius of 4 times your slant height of 9 plus pi times 4 squared. So at this point, there's two options of how it's going to ask you for answers. Number one, it will say just like to the nearest tenth. And then you can just type it all in and get a nearest tenth answer. Or if it says in terms of pi, you want to type everything in except for pi. So I would always start by doing 4 times 9 plus your 4 squared with pi on the outside. This chunk is going to be whatever you want in front of pi if you leave it in terms of pi. And then if you multiply by pi at the end, that will give you your other answer. So if you type that first chunk in, you'll get 52. So one answer would be 52 pi inches squared. Or you can type it all in and get 163.36 inches squared. Again, it depends on what the question is asking you, which one you need to write down. Two more examples. So if we're going to find the surface area of this cone in terms of pi, so you want to leave your answer in terms of pi. If it doesn't specify, it's up to you. I don't care if you leave it in terms of pi or put it in a decimal, but it will usually tell you which one it wants, especially on Math Excel. So the formula here is pi times the radius times the lateral or the slant height plus pi times the radius squared. So pi, here's our radius is 15, the slant height is 25, so 15 times 25 plus pi times 15 squared. And it wants it in terms of pi, so type into your calculator 15 times 25 plus 15 squared, and you should get 600 pi centimeters squared. And again, if it asks you for a decimal, you can just multiply 600 by pi and get your decimal version. So then the last one here we want to find, here it says lateral area of a cone, gives us a hint. But in a chemistry lab, we're using a filter in this funnel. So kind of like a coffee filter, we're putting a filter inside the funnel to filter stuff. We want to figure out how big does that filter have to be. So we don't need a top or a base to cover the top of the filter. We just need the outside edges. So we just need the lateral area. So here we want our lateral area. This is a cone, so pi times the radius times the slant height. Here it gives us the actual height again, so we're going to do the Pythagorean theorem. So I redraw this triangle here. You have 45 coming from this. 80 is all the way across, so we have to have 40 to get the radius or half of that. And then we're looking for RC. So 45 squared plus 40 squared has to equal our slant height squared. You'll get 3,625 is your lateral height squared. Lateral height is then 60.21. And then again, the radius is half of 80, so your radius is 40. So pi times 40 times 60.21. Type it all into the calculator, and you should get 7,566.21 millimeters squared. Just a note, with this entire chapter, you're going to get huge numbers and some small numbers and lots and lots and lots of decimals. So don't worry if you're getting decimals and like crazy big numbers. You should be getting those types of things. So optional homework assignment, you should be doing Math Excel 11.3. And that's it for 11.3.